shoe or whatever. So the API is also pretty straightforward. Like you need to inherit the custom tracker, and then you implement that track function, and you need to emit the track event. So this is a more advanced stuff, but that's how you create your own tracker if you want to track like car plates or whatever you want to track. And who's using that? There's many cool applications. Like this one is probably my favorite. The basic idea of this one is that it uses tracking.js, and once it detects my face, it's not going to put just a rectangle. It's going to put a different thing. So I can just record. And then it converts to a GIF. And then you can upload and share with your friends. So that's pretty crazy, right? There's this other one, like there's this band called Slipknot, and they were using that. It's not online anymore, I don't know why. But you would put your face, and then they would put some of the masks from one of the band members on your face, and you would feel like the band member. There's a lot of lessons that we learned by doing this, and things that we'd never expect. Like, I'm just a regular web developer doing my HTML, CSS, and JavaScript stuff, and we learned a lot just by like doing something different. One of the things that I learned is like the importance of performance and making things that are really perform really fast. When we see something in 24 frames per second, we think that this is pretty fast, right? But when we compare something like 60 frames per second, this one is now like, oh, this is so slow, right? Oh my gosh. And if you want to make something that it's really fast, it's really difficult, because in 1 second you need to, and you divide that by the 24 frames per second that you have only 41 milliseconds to run all your code for frame. So your code needs to be really fast. And if you remember the newest Hobbit movie, that's what they use to record their movies. Like, you have that weird feeling like, oh, this is weird. I don't know why it's weird. But they were recording the movie with 60 frames per second, and everything feels more like alive or natural or whatever. But it's a different feeling because we're used to 24 frames per second. This is the algorithm that we use to detect faces. This is the Viola-Jones algorithm that I told you. So basically what we need to do on every single pixel, imagine if you have a photo and we want to detect a face. I need to scan every single pixel from that photo like lots of times. And using this tracking algorithm, I need to try to identify if this part is a face or that part or that part. That takes a long time, and this is like in really, really slow motion and trying to show what it takes. Once it gets here, like it's running and it's confirming that, okay, the face is here, and then it runs again. And imagine doing that for a video where you have lots of images going on and you need to detect every single frame what's going on. So that's a lot of computing process that you need. Another thing I learned was typed arrays. In JavaScript, they have these new arrays that are really, really fast and makes things perform much better. Like if we compare things like how much does it take to have a bidimensional array versus int32 array, or not having an array at all, or having just an undimensional array. So the performance of those guys varies a lot. And even like math operations. If you compare AND operations, like plus with minus or multiplication, you figure out that, oh, on this part, instead of doing a multiplication, let's do just a sum, and this will make it faster. So, like, really low-level optimization. And by doing all those new, like, low-level optimizations, we could build some really crazy stuff.